So Analog Modules, we're an OEM electronics manufacturer. So we say that we make OEM electronics for the generation and the detection of laser light. So we have two sides of our product line. We make drive electronics for solid-state lasers, so for flash lamp pump and diode pump lasers. And then the other side is we make very high gain, very low noise amplifiers for small signal detection, and we couple those with photodetectors for applications like laser range finding and laser spot tracking. But we also do research things and what have you. But that's what we do.
Okay, so tell us what is new in this
so we
time.
have two big new products that we're featuring here at the show. First is our new flash lamp controller. So this is just the front, so it's just to show the exhibit, but it's so this is a complete controller for a flash lamp driven laser. So it contains the power supply, the simmer supply, the PFN electronics, and all the switching electronics. And so it has a touch screen interface. You can tell it how you want to fire. You can enter in your lamp information. You can do different delays through the Q switch. There's pulse rate modes. We can go continuous. We have burst, single fire, duty cycle. External, you can set it for external trigger mode. So it's an excellent prototyping tool or laboratory tool. And we can make it. We could screen it with your information if you want to make an OEM version of it. But it's all control. It's microprocessor controlled. It has USB interface. This one doesn't have the front panel, but the actual production unit has a front panel USB and a rear panel USB. So we provide a GUI. So if you want to use our GUI to control it, you can. But we also give you all the commands. You can do it remotely on your own as well.
So what is the limitation of the controller when?
So the limitations are that, so it's a 2 kilowatt driver, so 2 kilowatts is going to be your maximum average power. Mm-hmm. And then what can be how tolerant your system is for droop. So depending on the pulse width, as you get over, say you get into there's a limited amount of capacitance inside the box.
Yep.
So for longer pulse widths, you can get droop. But what we offer is you can attach additional capacitor boxes to hold up the droop over time. So the limit is anywhere between 10 to 20 milliseconds of maximum pulse width, but depends on how you're operating.
Yeah.
And again, the average power limit is at 2 kilowatts. But most people operating at like 20 milliseconds are operating very low duty cycles.
Yeah.
So the other new product we have is from the other side of the product line. So this is our model 7552. So this is a commercial laser range finding receiver and range counter. So what we've done here is we've taken an off-the-shelf InGaAs pin detector and the preamp. And again, the preamp is the core of our design. So the preamp is actually shielded to give it noise immunity from the environment. The post amps are mounted here, and then we have cable, however you need to have it, and then this is all the processing electronics. So this is the range counter, and so this will actually give you range information data on the output. So all in one package that's at a fraction of the cost of the normal unit. So we offer both the commercial and a defense version of this.
Yeah.
And basically the limitation is distance. So the commercial version of this is limited to under 3 kilometers, but it has no ITAR restrictions on it, just a standard commercial export type of device. But we have a version that we can go out to 15 kilometers and beyond, and that version does require an export license. So we offer the two options with different firmware that set the limit of the maximum operating position. But it's nice, we have the lower cost option for a commercial as well that does not require a license to export.
Yeah.
Those are our two big new things here at Analog Modules.
Yeah. So it's low cost, and what about the performance? Because when
very good performance. So with this, you're looking at a small signal detection of about 3 nanowatts from a 20 nanosecond pulse.
Okay,
so 3 nanowatts from a 20 nanosecond pulse. So the higher end receivers, they actually just operate at shorter pulse widths, but the same kind of responsivity. But by using a shorter pulse width, your accuracy goes up.
Yeah.
So because it's time of flight measurement, so that pulse width is setting that variation somewhere on that rising edge of that pulse is where the return is triggering for you making your time measurement. And so as you reduce the time variance of that rising edge, you increase the accuracy.
Yeah. Excellent. Thank you so much.
Certainly.
So thank you
Great.
so much.
Thank you for coming by.